Chapter 2 is atoms, molecules, and ions. We have spent extensive time last year in chemistry talking about atoms, molecules, and ions. What we're going to start in this chapter talking about is a handful of things, kind of a smorgasbord of what we learned last year in chemistry. We're going to review atoms and elements real quick. Then we're going to dabble in some math. When we start talking about empirical formulas and finding the formulas and percent compositions of compounds. And then we are going to review all the naming we learned from last year. So naming simple compounds, binary compounds, ionic compounds, naming acids, and naming organic molecules like we did at the very end of the last year. So there's going to be a lot of stuff packed into Chapter 2. In the first section here, we are really just going to focus on atomic theory and how we figured out the atom. And for the sake of the AP test, this really becomes a name game. So you have to kind of associate an individual with what they did. So first things first, our most prominent and most important chemist is going to be John Dalton. What did John Dalton do? He came up with atomic theory. What is the atomic theory? There's 5 points to the atomic theory, stating very simple but important facts about the composition of an atom and how an atom is composed. So if we look at this, first, each element is composed of extremely small particles called atoms. Seems like a common sense idea. However, when he was putting this together, that was a very noble and outside the box idea. Secondly, all atoms of a given element are identical to one another in mass and other properties. If they are different, if atoms are different, they're going to have different masses. All that means is an oxygen atom. If I have 2 oxygen atoms, they're going to have the same exact properties, same exact weight, same exact of protons, neutrons, and electrons. If I'm comparing an iron atom and an oxygen atom, they're going to have different weights and different amounts of protons, neutrons, and electrons. Atoms of an element are not changed into atoms of a different element by chemical reactions. Atoms are not created nor destroyed. What that means is I'm not going to change an oxygen atom into an iron atom. That cannot really happen. So atoms are not created nor destroyed. They can only be changed. Actually, and atoms really can't really change as well too much. So the atoms are going to stay the same. And we talked about this last year when we were balancing equations. I can't turn an oxygen atom into a nitrogen atom. That makes sense. However, I can take an oxygen atom, combine it with a nitrogen atom, and make something else. So I can't change atoms. So, and there's an infinite amount of matter on the universe, right? Since matter is never created nor destroyed. Next up, compounds are formed when atoms of more than one element combine. So a chemical reaction happens. Basically, right here, A plus B, whoop. Need to go back here. A plus B is going to give us AB. Or an A could represent an atom of anything, B could represent an atom of anything, and they're going to combine to form a compound. Now remember, the conservation of mass is what we were just talking about. Atoms are not created nor destroyed. So the total mass we start with in the reactants is the total mass that we end up in the products. We did this last year in a couple of experiments where we corked an Erlenmeyer flask, did a reaction, and weighed it before and weighed it after. You found out that the weight was the same. So keep in mind, very important law of conservation of mass. But Dalton is the one who deals with the atomic theory. So we have Dalton dealing with the atomic theory. Now we're going to start kind of influencing people who kind of made and discovered the composition of the atom. And next up is J.J. Thomson. J.J. Thomson is credited with the discovery of the electron. So we have Dalton with the atomic theory. We have J.J. Thomson with the electron. Thomson did an experiment measuring the charge to how many electrons there were and came up with a unit. Now, you don't have to know that number. That number is not incredibly important. If you need it, it would be given to you. Next up, now we need to kind of figure out, now that we have the charge to mass ratio of an electron, once J.J. Thomson kind of discovers the electron, now we got to kind of figure out a little bit more about the electron. So what's going to happen with the electron? And what happens is Robert Millikan really tells us the electron is negatively charged. So he determines the charge of electron in 1909. It's negatively charged. So we have Dalton, atomic theory. We have Thomson, discovery of the electron. Millikan, figuring out the electron is negatively charged. Now, when we start talking about figuring out the atom and the composition of the atom, we dabble a little bit in radioactivity. What is radioactivity? It's really just the spontaneous emission of radiation by an atom. There are three types of radiation. It was first observed by Becquerel, and Marie and Pierre Curie also studied it very intensively. In fact, they won the Nobel Prize for it about 100 years ago. There are three types of radiation discovered by Ernest Rutherford. There's alpha particles, there's beta particles, and there's gamma particles. Alpha particles are positively charged, beta particles are negatively charged, and gamma particles have no charge. They are neutral pieces of radiation. So something to kind of keep in mind here. Alpha is positively charged, beta is negatively charged, and gamma is neutral. Ernest Rutherford discovered the three types of radiation. So now we have the atom. And if you can remember from last year, the prevailing model of the time was the plum pudding model. Plum pudding, a popular dessert, not in the United States, but across the pond. And what you have here is that the whole atom is positively charged, and sprinkled throughout it is electrons. So that's not the case really, though, all right, as we know. But plum pudding model, that's around 1900, so a little over 100 years ago. Then Ernest Rutherford. All right. Ernest Rutherford also discovers the nucleus. So he has three types of radiation and the nucleus. And he figures out that this model is not correct. By doing a couple of experiments, he finds out the plum pudding model is not the correct way. Then Rutherford said that the nucleus is incredibly dense. So we have Rutherford again coming through. Again, he has the three types of radiation and the discovery of the nucleus, which is solid. It's a very important discovery in chemistry. Then, since he discovered the nucleus, what we have is we have to figure out what the nucleus is made out of. Rutherford also gets protons. But neutrons were not discovered for over almost a decade and a half, in 1932. So we have neutrons by James Chadwick. So kind of review our names here real quick. We have Dalton is the atomic theory, and his points, 4 points really in the atomic theory. We have J.J. Thomson with the discovery of the electron. We have Chadwick discovering the negativity of the electron, the charge of the electron. We have Rutherford figuring out three types of radiation and that the nucleus is incredibly small and incredibly dense. Rutherford also figures out that protons are positively charged, and then Chadwick comes along with neutrons have a neutral charge. Now, if you want to look at the mass, you don't have to really look at the mass. We know that protons are positive, neutrons are neutral, and electrons are negative. All right, that will conclude kind of section 2.1 of the notes. It is kind of a naming game, so really make sure that you're able to know the scientists that we talked about and the importance when it comes to naming them. If you have any other questions, I will be able to answer them on Tuesday.